Hello everyone, I am Athar Chauhan and in this part of presentation we are going to explore how we can partition student project scores using three different techniques: equal frequency, equal width and clustering. This helps us understand how each method handles uneven and widely varying data. Now, understanding the dataset. Our dataset contains 12 student project scores ranging from a very low 5 all the way up to 215. So, the variation is huge and there are noticeable gaps in the distribution. We aim to divide these 12 values into three meaningful partitions using different approaches and compare the results. In equal partition, Method 1, equal frequency partitioning. In equal frequency partitioning, each group contains the same number of values. Since we have 12 values and want 3 bins, each bin will contain 4 scores. The partitions are bin 1, 5, 10, 11, 13; bin 2, 15, 35, 50, 55; bin 3, 72, 92, 204, 215. This method guarantees perfect balance. Even though the ranges are very different, each bin get exactly four values. That is why equal frequency works well for skewed or uneven distributed datasets. Method 2, equal width partitioning. Equal width partitioning works very differently. Here we divide the entire range into equal sized intervals. Our score range is 215 minus 5 equals, which gives us 210. So with three partitions, each bin has a width of 70 points. This gives us bin 1, 5 to 75, 9 values; bin 2, 75 to 145, 1 value; bin 3, 145 to 215, 2 values. This method clearly struggles with our dataset. Most scores are crowded in first bin, the second bin barely has any values, and the third bin has only 2. Equal width is simple, but it doesn't handle skewed distributions well. Is the result of equal width partitioning. Method 3, clustering based partitioning. Clustering gives us the most natural groupings because it assigns scores based on similarity rather than equal count or equal ranges. The cluster become cluster 1 low performers 5, 10, 11, 13, 15; cluster 2 medium performers 35, 50, 55, 72, 92; cluster 3 high performers 204, 215. Here we can clearly see three logical performance levels: a group of low scorers, a middle group with moderate scores, and high achieving group far above the rest. This method respects the natural structure of the data. Now, why clustering works best? Clustering is especially powerful for dataset like us because it creates meaningful groups based on similarity. It adapts to natural patterns in the data. It captures big gaps in performance. It tells us which students are struggling, which are average, and which are excelling. In real educational data, clustering is often the most insightful method. Now, comparing all methods, to summarize, equal frequency gives balanced bins but may mix very different values. Equal width is simple but performs poorly with skewed data. Clustering reflects natural performance levels and is the most meaningful for interpretation. So, while all three methods are useful, clustering gives the clearest understanding of student performance. This is the comparison of the strength and weaknesses of about three methods. Now, the key takeaways. To conclude, partitioning helps us break complex data into understandable groups. Each method has its own strength and weakness. For this dataset, clustering based partitioning gives the most useful results because it handles uneven distributions effectively. I hope you liked my video. Thanks for listening. Thanks for watching. See you again.